Find the derivative with respect to x of this function. Well, this function, it wouldn't be bad to look at the graph of this function, because there's something going on with this function at x equals 3. If we look at this graph, and consider what's happening to the left of 3, or at 3 itself, it's defined by the expression 2x minus 1. So a couple of key points, and we can draw a piece of a straight line. 2 times, right at 3 itself, 2 times 3 is 6, 6 minus 1 is 5. So 1, 2, 3, 4, 5. Goes through the point 3, 5. And the y-intercept is negative 1. So this is a piece of a straight line. And what is the slope of that the piece of the straight line? It's 2, right? Now, on the other side of the 3, if we evaluate the function at 4, for example, 4 minus 4 is 0, because we have to use this expression to evaluate it when x equals 4. So 4 minus 4 is 0. 4 minus 5 is negative 1. 4 minus 6 is negative 2. If you write it negative x plus 4, maybe it's easy to see that has a slope of negative 1. Now, I've left off what's happening between 3 and 4. The function is defined between 3 and 4, and it's going to continue up this way. And if we evaluated the limit of f of x as x approaches 3 from the right, that would be the limit of 4 minus x as x approaches 3 from the right, because that's how the function is defined when x is greater than 3. 3 values a little bit more than 3, so that's 4 minus 3, which is 1. So the point 3, 1, I can't really call it a hole in the graph, but it's a boundary point for the graph. And so the graph goes up to it, but does not include it. Would you guess that this function is going to be differentiable at 3? It's not continuous at 3, and what we'll learn, if I can talk fast enough, is that a function has to be continuous in order to be differentiable. And there are actually some good examples of functions that are continuous but still not differentiable. But this one is not going to be differentiable at 3. Let's see what we can say about its derivative. At any point in the interval, let me write this, f prime of x equals blank if x is less than 3. Notice I deliberately left off the or equal to bar. There's an or equal to bar here, but there's not an or equal to bar there. Deliberately left it off because we can easily define a function, easily indicate the derivative of a function in an open interval, but it's tricky what happens at the endpoints. So this function is differentiable on the open interval from negative infinity to 3 because it is equal to this really nice linear function on the interval from negative infinity to positive 3. So the slope of the tangent line, notice I'm not going to do the delta x thing here, but the slope of the graph all the way to the left there is 2. Pick an x, any x less than 3, the slope is 2. On the other hand, if I pick any x greater than 3, what's the slope going to be? Negative 1. So that catches all real numbers in the domain of this function except the number 3. Got to figure out what's happening at 3. Now that takes as much work as all the rest combined. Figure out what's going on at 3. So I'm going to take this and put it off in a little corner somewhere. There we go. And let's find the limit as delta x approaches 0 of f of 3 plus delta x minus f of 3 all over delta x. Now it's going to turn out to have issues. We're going to end up having to evaluate both the one-sided limits, delta x approaches 0 from the right and delta x approaches 0 from the left, and then compare them, because the delta x's are not going to divide out in one of these two cases. So, well, let's simplify it a little bit until we get to the point where we realize this. This equals the limit as delta x approaches 0 of f of 3 plus delta x. Well, here we go. Delta x is a small number. Well, if it's approaching 0, it's eventually a small number. But it might be positive, it might be negative. So 3 plus delta x, I've got to answer the question. If I'm going to evaluate this, replace this with one of these, I've got to know, is 3 plus delta x greater than 3, or is it less than 3? It can't be equal 3 because delta x is not allowed to get to 0, just real close. And the answer is this. It depends. If delta x is positive, then 3 plus delta x is greater than 3, so we use this rule. On the other hand, if delta x is negative, then 3 plus delta x is less than 3, so we have to use that rule. So we got to break it apart into two cases. If we're going to simplify this, we have to think, okay, is it approaching from the right or from the left? So let's say it's approaching from the right. No. Let's do the left first. Approaching from the left. It ends up behaving badly as it approaches from the right. So let delta x approach 0 from the left. Now we know that 3 plus delta x is less than 3, so we can use the 2x minus 1. So it's going to be 2 times 3 plus delta x minus 1. And then what is f of 3? It's 5. We put the 5. All over delta x. So we keep going. This equals the limit as delta x approaches 0 from the left of 6 plus 2 delta x minus 1 minus 5 all over delta x. Well, the 6 and the minus 1 and the minus 5 all add up to 0. So we'll cancel them all. A group cancellation there. This equals the limit as delta x approaches 0 from the left of 2 delta x over delta x. And I guess this is not a big surprise. This is the limit as delta x approaches 0 from the left of 2, which is 2. Okay. Well, that part of the limit exists. I guess that's not the final answer, so you shouldn't put a box around it. Hope that wasn't important. What I should do is find the limit as delta x approaches 0 from the right of f of 3 plus delta x minus f of 3 over delta x. Now, delta x is a little bit greater than 0. So 3 plus delta x is a little greater than 3, and if it's greater than 3, we use the bottom rule for evaluating the function. So this is the limit as delta x approaches 0 from the right of 4 minus 3 plus delta x. But f of 3 is still 5. And that turns out to be a problem.
Why is it 5 again?
Well, just because in the original rule that defines the function, the or equal to bar is up there. So still 5. So imagine what a secant line would look like. If we've got a secant line, this is our point, CF of C, 3f of 3. But now, if delta x is positive, we're considering points to the right of that. So points like right there. And we're wondering, what's the slope of that line? And then maybe as delta x gets closer to 0, we look at the slope of this line. And as delta x gets a little closer to 0, we look at the slope of this line. And as delta x gets really close to 0, what's happening to the slope? And yeah, it's going to a point where we're not going to be able to define the slope. See, the slope of this line is maybe what? Oh, negative 7 or 8, then maybe negative 10, maybe negative 20, maybe negative 100. Maybe it's approaching negative infinity. Let's see what goes on here. This is going to be the limit as delta x approaches 0 from the right of 4 minus 3 is 1. 1 minus 5 is negative 4. So negative 4 minus delta x over delta x. Delta x is not a factor of the numerator. It's a term, but I can't factor the delta x out of the numerator. If you want to, I don't know if you'd want to, maybe you would. This is the limit as delta x approaches 0 from the right of negative 4 over delta x minus delta x over delta x. Yeah. So take the delta x over delta x and call that 1 because it's equal to 1 for every value of delta x, since delta x doesn't equal to 0. As delta x goes to 0 through positive values, the denominator is going to, well, small positive value. Negative 4 divided by a small positive value is a great big negative value. So this equals negative infinity. That's what's happening to the slopes of these lines as we go from the right to the left there. They're getting steeper and steeper and steeper, arbitrarily steep. So the slope of the tangent line is approaching negative infinity. This limit does not exist, and this function is not differentiable at 3. So we leave it. We're looking for the derivative. We leave it, like, trying to circle it, having a hard time. We leave it like this. That's the derivative. It's 2 if x is less than 3. It's negative 1 if x is greater than 3. It's undefined otherwise.